Hello, and welcome to Learn How Transdev / Disaster Recovery Costs by 73%. My name is Carmen Puccio, and I'm a Principal Solutions Architect here at AWS, and I'll be your host and moderator for today's presentation. In addition to learning about AWS, we will also hear from Stephen Timms, who is an EVP of Global Sales at Cloud Endor, and we will also hear from Matthew Traverse, who's an IT Lead Architect at Transdev. In this webinar, you will learn how to determine if a DR solution can reliably protect all of your applications, including databases and write-intensive workloads, how to leverage the flexibility of AWS with the right DR solution, how to save up to 80% on your disaster recovery approach, and how Transdev increased IT resilience and future-proofed their business. So remember, please post your questions in the chat box throughout the presentation as we will review questions at the end of today's event. Okay, so let's get started. So before we get to Transdev and Cloud Endor, because I know that's what you're here to hear about, I'd like to talk a little bit about disaster recovery and set the stage. I want to talk about the business and technical drivers for why companies look to facilitate disaster recovery in the cloud. And DR is usually about preparing for and recovering from a disaster. Any event that has a negative impact on a company's business continuity or finances could really be termed a disaster. This includes things like hardware, software failures, network outages, power outages, physical damage to your building, something like a flood or a fire, human error, or any other real significant event. And traditionally, customers would try and achieve this disaster recovery by creating a like-for-like environment for their applications. And while this allowed them to fail over during outages, it proved to be costly because they would essentially be paying double for that just-in-case moment required to keep their applications up for their customers. And businesses are using the AWS cloud to enable faster disaster recovery of their critical IT systems without incurring the infrastructure expense of a second physical site. So the AWS cloud provides or supports many popular disaster recovery architectures, something like a pilot-light environment, which we'll talk about in a little bit, that may be suitable for small customer workload data center failures to hot standby environments, which we'll also talk about, that enable rapid failover at scale. So with data centers in regions all over the world, AWS provides a set of cloud-based disaster recovery services that enable rapid recovery of your IT infrastructure and data. If you also think about it too, like managing hardware and not necessarily being able to test and deploy your applications in a very seamless manner in your traditional IT portfolio is something that the AWS cloud provides. So if you think about it, like something as simple as like hardware refresh cycles in your legacy environments, now you have the ability to test your application code as part of your DR strategy on newer EC2 instance types as they're released with just a click of a button. So we're going to talk a little about DR strategies, but I want to emphasize that DR is really about policy and controls. So after your DR solution is in place, it needs to be tested, and you want your teams to be completely and well-versed in all of the strategies and processes that go along with your DR plan. And you should always test frequently. And this is one of the key advantages of deploying on AWS. I talk to customers and they run game day scenarios, which is when you have an exercise for failover to your DR environment, ensuring that the sufficient documentation is in place to make the process as simple as possible should the real event actually take place. Spinning up that duplicate environment for testing in these game day scenarios is really quick and cost effective on AWS, and you don't need to actually touch your production environment. You can use things like AWS CloudFormation to deploy complete environments on AWS in something like another region, right? And this uses a template to describe the AWS resources and any associated dependencies and runtime parameters that are required to create that actual full duplicate environment. Differentiating your tests is key to ensuring that you're covered against a multitude of different types of disasters. And these are some of the game day scenarios that I talk to customers about. And again, it's that power loss to a site or a single set of servers. Maybe you've lost connectivity from your ISP. Maybe it's a virus that's impacting your core business, and you want to make sure that you can flip over to another site quickly and effectively. Or maybe it's even user error that causes like the loss of data, requiring you to go to a point in time. So just to familiarize you with the terms, so RPO and RTO, what are they? So RTO, or recovery time objective, This is the time it takes after disruption to restore a business process to its service level. And this is defined usually by an operational agreement. For example, if your disaster occurs at something like maybe 12 o'clock or noon, right, and the RTO is an hour, the DR process should restore the business processes to an acceptable service level by 1 p.m., right? And then RPO is the acceptable amount of data loss measured in time. So again, if your disaster happens at 12 o'clock or noon and the RPO is 1 hour, the system should recover all data that was in the system before 11 a.m. Data loss will only span that 1 hour between 11 and 12. So a company typically decides on an acceptable RTO and RPO based on the financial impact to the business when systems are unavailable. And the company determines financial impact by considering a lot of factors, things like loss of business and damage to reputation due to downtime and the lack of systems availability. So IT organizations then plan solutions to provide cost-effective system recovery based on RPO when the timeline and the service level is established by the RTO. So what you're seeing here is, a couple of different approaches on how you can achieve DR on AWS. So you can see how they're kind of aligned based off of cost, and I just want to go into each one at a high level. So the first one is backup. So if you think about like traditional environments, data is backed up the tape, sent off site, and this is something that's done regularly. And if you use this method, it can take a long time to restore your system in the event of a disruption or a disaster. And something like Amazon S3 is an ideal destination for backup data, that might be needed quickly to perform a restore. Transferring data to and from Amazon S3 is typically done over the network, and therefore it's accessible from any location. Pilot Light is a popular way of achieving DR, and what that is it's essentially a minimal version of your environment, and it's always running in the cloud. The idea of a pilot light is an analogy that comes from a gas heater. In a gas heater, there's that small flame that's always on and can quickly ignite the entire furnace to heat up your house. So the scenario is very similar to a backup and restore scenario. So for example, with AWS, you can maintain a pilot light by configuring and running the most critical core elements of your system in AWS. And when the time comes for recovery, you rapidly provision a full-scale production environment around that critical core. Warm standby is another approach, and this is typically used to describe a DR scenario where there's a scaled down version of that fully functional environment, and it's also running in the cloud at all times. And a warm standby solution extends that pilot light elements and preparations, but it further decreases that recovery time because some services are always running. So by identifying those mission critical, business critical systems, you can fully duplicate these systems on AWS and have them always on. And then lastly, there's multi-site. And multi-site solutions run in AWS as well as your existing on-site infrastructure or in another region. And this is that active-active configuration. And the data replication method that you employ here will be determined by the recovery point or RPO that you choose. So it boils down to an application lifecycle and figuring out which technique you should take advantage of. It really boils down to that RPO and RTO that I was talking about before, and the cost associated with the techniques you saw on the prior slide. It's very important to realize that besides taking advantage of AWS services or AWS building blocks to meet your RPO and RTO, there's fantastic tools out there like Cloud Endor, which we're going to talk about today, that you can take advantage of to help meet these requirements. So with any application, there's a wide spectrum of complexity when trying to figure out the DR strategy. With AWS, you can design an effective disaster recovery plan that allows you to prioritize your costs and also allows you to take control of those building blocks that I was talking about before to build your DR solution. The key advantage here of using AWS services is that you're only paying for what you use. So think about it in that light switch mentality. You're paying for your environment as you run your tests as part of your game day scenario, and then as soon as you're done, you turn it off. And that gives you the confidence that you need to make sure that when it is time to flip the switch, regardless of the type of application it is, you know that your IT teams are able to safely fail over to the other environment running wherever it may be inside the AWS cloud. So I want to highlight our global footprint. The AWS cloud today spans 55 availability zones with 18 geographic regions, with more announced, more on the way. right? So if you think about this and you think about our point of presence around the world, and you should have a very easy time figuring out your multi-region strategy. So, maybe you run your core applications inside of something like US East 1 inside of Virginia, and maybe you spin up that pilot-light architecture over in one of our Western US regions. Having this large point of presence allows you to easily spin up, and spin down your applications based off your RPO and RTO needs, regardless of where they are in the world. So I want to highlight really quick our AWS services, and I always like to make a point that we're constantly evolving our services, and we're trying to make it easier for customers to move their workloads over to the cloud. So regardless of whether a customer is trying to move a server, a database, data, whatever it may be, there's the services or your building blocks and the tools that help you with a disaster recovery strategy. They all share a common goal, and that's to facilitate that DR plan in AWS by minimizing downtime, application workload impact, and it's trying to minimize that data loss. It's trying to meet those requirements that you've specified in that RPO, RTO. And lastly, I want to highlight the AWS Marketplace, which is an online store that helps customers discover and purchase and migrate and immediately start using the software and services they need to build and run products for their business. So visitors to the marketplace can use the AWS Marketplace's one-click deployment to quickly launch pre-configured software. And again, you're only paying for what you use by the hour or the month, and AWS handles the billing and payments, and software changes appear on the customer's AWS bill. There's fantastic technology partners in there like Cloud Endor, and the AWS Marketplace allows you to easily take advantage of products like Cloud Endor as part of your DR strategy. So with that said, I want to pass it over to Matthew, and I want to let him tell his story around Transdev and their DR journey into AWS.
Hey, thank you, Carmen. I'm really happy to be here to share with you what we've done with this project. So I'm Matthew Travers. I'm an IT lead architect working for Transdev Global CTO. Who is Transdev? So Transdev is a French global mobility company. We are 82,000 people and with a unique mission, which is moving people everywhere in the world. So we have a presence from New Zealand and South Korea to the US and Chile, and with an historical, really huge presence in Europe. There are 3.5 billion passengers that are using our service each year, and we have a really large fleet of vehicles, and especially a large fleet of vehicle types. We have vehicles like bus, trains, on-demand cars, ferries, but also shared bikes and autonomous shuttles. So if you have already used collective transportation somewhere in the world, you probably have already used our services. Transdev is a former transportation company which became a mobility company. And you can ask yourself, why did we change our mindset? And in fact, you have to know that transportation is one of the first business that has been disrupted by new players coming with new innovative ideas. So we had this need to evolve and to adapt to these new competitors. So we had a challenge regarding our DR solution. We had this challenge to rebuild it because we had some issues with the existing infrastructure, and we chose to completely rethink our DR approach. As a traditional company, we have a traditional IT infrastructure, and this traditional infrastructure is supporting our traditional applications. So due to asynchronous hardware and software upgrades between our primary site and the backup one, we start to face some difficulties and some issues with compatibility, some end-of-life products, and we had this need to rebuild RDR because we had a corporate security plan which was done in this same time frame, and this would have led to a consequent investment to renew all hardware and licenses on the backup site, and a huge amount of time of our infrastructure teams. So we had waited the most that we could with the existing infrastructure, but this corporate security plan scoped new applications for the year, and the existing infrastructure was nearly out of capacity. So we had a 6-month time frame to choose and deploy a DR for an initial scope of 20 applications that represented around 80 Windows servers. And finally, besides this project, we were starting our journey to the cloud and to the AWS cloud. So we were not really willing to be long-term committed with an expensive infrastructure, which could have slowed down our objectives to move to the cloud. And there were also the renewal of our hosting provider contracts approaching. So we started to study we're starting a study to find really the best option possible to rebuild our recovery infrastructure. So we were looking for the best option available on the market, and we had a scope to cover which was really clearly identified. It was coming from previous infrastructure, and especially from previous infrastructure service level, and the objectives were given by our application owners and the corp security plan. So the scope was the following. Only a subset of our entire application landscape was eligible. As I say, 80 servers for 20 applications and all the dependencies of each application. We had a uniform RTO and RPO expectation to 24 hours for each of our applications, except one, which has an objectives which was expected, which were to 4-hour RPO, sorry, and 8-hour RTO. So it was really identified since the beginning of the project. And most importantly, we have to cover the loss of the entire primary data center. That means that we need from the beginning that what we had to cover was the entire loss of the data center. And when I mean the entire loss, I mean a complete disaster without any chance for the service to be short-term back available. As my boss has always been convinced that DR was one of the most suitable workload for the cloud, I had to be as well. And back to the definition of cloud computing, you only pay for what you use. Back to the definition of disaster recovery, you have a standby infrastructure ready for failover in case of a disaster of the primary one. So that means that these two definitions seem clearly match one another if you find the right solution to have a minimal running infrastructure in nominal mode. We do not need at Transdev to be a disaster recovery expert, so it's not our business differentiator. So we want to have business continuity, but without the need to be really a technical expert on the air. So we try to find that tool which can ensure our objectives for recover time and recover point. And we also looked for a partner to manage it. We tried several solutions and none of them was really matching our requirements. In some cases, we had uncertain recovery times and predictable recovery times, or some part of the scope were really not completely covered. And in other cases, it was not relevant from a cost standpoint. So we were about to give up and redo the things as we did for a long time when both Amazon and one of our partners came to us with the Cloud Endure solution. So as the solution seemed to meet our needs, we decided to give it a try. And in 1 month time frame, we studied internally the cost to be sure that it was relevant from what we expected from a cost perspective. And we did a POC with our partner to validate the ease of use and the performance of the solution. We took so much time looking for the best solution that we did not want we did want this POC to be really quick and relevant. So When time came to choose the application on which we will run the POC, we chose our most complex application technically wise. And in this one most POC, it was around 20 servers for this the POC for this really complex application. Around 20 servers with 2 Microsoft failover clusters and 1 running SQL server, and 2 different ways for the users to access it, either from a web UI or for a standard client through a Citrix farm. We did this POC, as I said, really quickly in that month, because we wanted to be really sure as soon as possible that the solution will cover all our needs. So the initial replication phase was really quick. We used an IPsec VPN connection, and we could test the recovery process really soon. The OS recovery time was quick as well, and it permits us to work on the application recovery, validate it was feasible within the expected time. We also validate all that all the items in our DR script were covered by Cloud Endure solution, even the few physical servers we still have. The replication to block storage makes the recovery time predictable and consistent. And the needed agent to handle the replication is really installed in a few clicks. From a security perspective, the ability to replicate the data through a private network gives us additional confidence that our data is protected even in transit. And from a management perspective, as the API are publicly available, our partner was able to develop a management platform above Cloud Endure based on the Cloud Endure API and the Cloud Endure engine to put our custom recovery logic with our priority, batch of servers, and orchestrations. In fact, everything that is our way to recover for this particular for our particular environment. You may have some services that must be available before some applications, some applicative services. So all this orchestration process has been done through these tools above the replication engine. Then we deployed the solution itself, and here is the high-level infrastructure in place. So as you can see, we still have a dual data center infrastructure, but the backup data center is now no more hosting compute resources. It's a network-only data center, because if we have the need to fail over from our primary site, we need to have all our network equipment available to in another location. But the good thing is, as we had our contract renewal approaching, we renegotiated from a dedicated room in the hosting area to a shared rack. So it's really cheaper now. This secondary site is really cheaper now. So in AWS, we chose to create an account dedicated for DR purpose to isolate the workload. This is really important because in this case, you won't share the limits of the account with other workloads. And this is really something important that I will come back later. And this is also make it really easy to identify the costs of the DR infrastructure. Then in this account, we set up 2 different VPCs, one for replication, which is the staging VPC, and it's constantly connected with our primary site. It contains all the replication engines and the replicated volumes. In our case, the replication fleet is composed of 15 lightweight servers. And then there is a second VPC, which is not connecting to the staging one or to the data center, which is free of resources, and which would host the servers of replicates in case of test of failover. This one can be connected to our backup network data center or to the staging VPC on demand. So for what we have achieved, so it's now been a year. We have RTO on AWS with Cloud Endure. It's running to protect around 70 servers, and it represents around, in fact, a little more than 20 terabytes of data. We managed to reach an RTO around 4 hours with a near zero RPO. We also have everything managed by our partner, taking care of the monitoring, taking care of the updates, and as well as organizing the tests. If we have a disaster, we just have a phone call to pass and ask them to start the recovery process. We also convinced our colleague from the US, Transdev in the US, to migrate their DR infrastructure to Cloud Endure. And the project just started with the setup of the Cloud Endure and the AWS accounts. We will start the replication operations in the coming weeks. Now, if we look closer to some metrics we got since the beginning of the project, we can see that the costs have been improved, as well as our capacity to fail over in the expected delay. You can see that the initial replication was done immediately during the 2 first months. We had our first applications and the mandatory technical services available. As soon as everything was available, we started the first test where everything was done manually. Right after, the next week, in fact, we did a second one, and you can see that we dropped the recovery time by a third, but we were still not achieving our expectation. Then we took some time to automate most of the thing based on our previous experience, and we took this time to automate, and we finally reached in September the expected objectives for RTO. And now, if you have a look at the curves, you can ask, why did the curve goes down in December despite the volume stays the same? We found out that we could even improve the platform from a cost perspective by moving our replication volumes from standard performance to basic performance, decreasing the cost without impacting the performance, as the replication is optimized enough. And finally, I like to give you all that we learned building this new platform, and I think it can be really useful to share with you all these outcomes. First, you have to know what you need to protect. The criticality of an application should be defined by the business, and maybe not all your applications need a recovery plan in a matter of minutes, or it could be maybe acceptable to have the data of the previous day restored. That means that you can choose the RTO and RPO per application. So maybe not all your application needs this kind of service. And in this case, you will maybe prefer to focus on the business critical application, and then you could restore the service for other application with maybe some kind of backup and restore approach. In our case, only 10% of the total number of our servers were scoped in the project. Then, really important as well, the sooner you replicate your data elsewhere, and the sooner you're protected. That does not mean you'll be able to meet your objective yet, but at least you can bring the service back online. As I said, maybe not all your application will need the same objectives for recovery, so you have to find the right objective to ensure for the right applications. We expect the unexpected will happen, and we want to be prepared as much as possible. It can happen in the cloud, but it can happen in our data center as well. So try is is really a good thing to do. And you do it to improve. The more time you'll test and the more improvement you find, and believe me, you'll probably rediscover your application and infrastructure and find improvements to be done on your primary environment as well. You'll also increase knowledge around the DR itself and every covered application. Every time we did the recovery tests, we found something to do better, especially by automating the recovery actions, and this event with this partnership. Now, I'll give it over to Steve from Cloud Endure, who was our main contact for this project.
Matthew, thank you very much. And just while the slide changes, I want to say congrats on your implementation, the successes that you've achieved so far. And thank you. It was a great job in articulating why I think cloud-based disaster recovery is so advantageous, and the value of implementing Cloud Endure. So thank you for that. So again, quick introduction, Stephen Timms. I run the sales organization here at Cloud Endure. Good morning, good afternoon, and good evening. And over the next few minutes, what I'd like to do, I think, is reinforce some of the content that Matthew did such a good job in sharing, and maybe share with you some more information about Cloud Endure. So again, to reaffirm, Cloud Endure takes full advantage of what Carmen very well described as the broad range of AWS infrastructure options. And that allows us to create this warm standby, what we call a staging area, which is low cost, but without compromising the performance. You heard from Matthew that with Cloud Endure, it's robust and consistent in ensuring this reliable protection. The in-memory operation of the agent, which we'll talk about momentarily, is really, really quick, and it works so well that this is how we're able to cater for even these very write-intensive workloads like highly transactional databases. And then the last point is, by operating the target grade infrastructure only when you need it, by otherwise running in this staging environment, our experiences, our customers are able to shed 80% or more against the traditional cost of ownership compared to typical on-prem disaster recovery options. So I'm going to walk you through the architecture now to give you a sense of how this thing hangs together. So we begin with the source, and in this case, our source can be an on-prem data center, and that can be a physical machine, it can be virtualized. Cloud Endure doesn't care. It's possible that you could also be doing, as Carmen suggested, AWS region to region. So if you've already been through a migration journey, Cloud Endure can still help create low-cost disaster recovery with high performance by simply doing this very process from region to region instead of on-prem to AWS. Regardless, the first step is to use any of your standard unattended or automated installation tools to install an agent on the source machine. And if you are running in a hypervisor, this would be at the guest level. So this is the operating system. That agent is going to identify some metadata about the source machine, CPU, RAM, for example, and more importantly, identify how many disks are attached and the size of each disk. Having done so, the next step is for you in your target VPC is to create a subnet. That subnet we're going to call the staging area, and you can think of that staging area as a private place for Cloud Endure to create this warm standby environment. So we manage and own all of the resources on your behalf in this staging area. The first thing we're going to create is a duplicate set of storage. So it's the same number of disks and the same size of disks using low-cost magnetic EBS. And this is simply going to be a data repository. We're not going to front this with any meaningful compute. What we will do is create a small server. We call it a Cloud Endure replication server. It's a small low-cost server, and the sole job of the replication server is to be the endpoint of the agent traffic to take the blocks and pass the blocks out to the relevant disks as necessary. So once we install the agent and the agent's able to connect over to the Cloud Endure replication server, it works in one of two modes. The first is what we call initial sync. At this point, the agent will actually read the source disk in its entirety at the block level. So this is block level replication, which means we actually don't see, much less care, what data, applications, databases, operating systems we're protecting, because all we see is the physical level of the block device. And that's good for you because it means that we can replicate any type of workload as long as it is supported in AWS. So after the disk has been read in its entirety, that's when the agent moves into what we call CDP, or continuous data protection mode. At that point, all agent activity will be done in memory. It will sit there acting as a filter, a write filter for the OS to the images. It will capture in memory the blocks. It will package that information and send that over to the Cloud Endure replication server. When we talk about packaging, essentially, it will both compress, typically between 50 and 70%, and encrypt using AES 256-bit encryption. The data path will go directly from source through to the staging area across whichever route you've preferred, which could be a direct connect, a tunnel, or across the internet. Again, it's AES 256-bit encryption, and it will go directly from source to target, never through a Cloud Endure server. Okay, so hopefully what I've been able to articulate is, after the initial sync and the agent moves into CDP, any transactional activity that occurs on the source machine will be captured, any disk transaction activity will be captured in real time, compressed, encrypted, sent directly to the replication server, where with a sub-second RPO, it is written out to its relevant reciprocal EBS magnetic disk. Okay, this in the world of disaster recovery is really business as normal. So as our source workload continues to operate, we're simply farming out block by block this packaged, encrypted, compressed blocks over to our staging area. In order to create our target resources, Cloud Endure first needs to learn some metadata about the resources that we're going to create. We call this metadata a blueprint, and a blueprint is going to be the kind of information that you yourself would create when you are going to create an AWS instance and attach storage. So it's going to tell us things like the instance type, what subnet, IP addresses, security groups, what sort of storage we want attached, what tags we want to apply to the machines. This is the information that we need ahead of time. And that's because this is the information that Cloud Endure is going to consume as we call the AWS APIs to launch these resources on your behalf. Okay. Once the blueprint has been defined, we're in a position for you to execute your target resource creation. And that's going to be either in the mode of testing, and you heard Carmen talk about just how easy it is to test. And with Cloud Endure, it is a very simple process. It's conceptually a single button press, and you're able to launch test instances to run, perform your DR strategy, confirm your testing works as appropriate, and then close down the resources using Cloud Endure, and then continue in the background this continuous data protection between source and the staging area in the interim. So in order to do that, you'll be given a choice of either using the console, or as you heard Mathieu described with Gecko, they're actually calling Cloud Endure's own APIs to create and effect the target resources. So whichever way you do it, here's the choice that will happen. You'll be given the choice of either creating the production resources or the target resources with a sub-second RPO, which really means the latest, the very latest copy that we have in the staging area, or one of 60 historic snapshots. And that's going to graduate in periods of time between 30 days. So for the first hour, it's every 10 minutes. then it's every hour for the first day, then it's once a day for the remaining 30 days. So you have the very current latest or historic snapshots. If you choose latest, we will actually take a real-time snapshot at that point in time. Having identified which snapshot is the snapshot to move over to the target production resource side, we'll move that snapshot over to the production storage that was defined in the blueprint. At that time, Cloud Endure is going to evaluate whether the destination hypervisor is different from the source hypervisor. So in the example of coming from a physical or a VMware machine to AWS, that's clearly the case. If we're doing AWS region to region, that clearly isn't the case. So if we do need and do evaluate that it is a different hypervisor, Cloud Endure will create a temporary instance of the Cloud Endure machine converter. And its sole job is to live momentarily enough to inject the necessary driver files and config files for the boot machine. Once that's done, Cloud Endure is at a place where we can create the instance that was defined in the blueprint, to mount the volumes and reboot the machine. What we end up with is the sub-second RPO between source to the staging area, minutes to create the staging area to the live production instance, and we have a working copy within minutes. The last piece of the puzzle here is you can deploy at source a script into a particular folder, and as we do that first post-launch, we'll run that as a post-launch script. So this would be a good place, for example, to tidy up VMware drivers or perhaps uninstall a particular antivirus. That's the place that we would do that. So this is the process that we work through. This is the process that you can do using Cloud Endure Console, but as Matteo described, what Gecko, which is the partner that's been working with Transdev, what Gecko did was to use Cloud Endure's APIs to create a uniform UI that does much of this activity and more on behalf of Gecko and Transdev. So that's the process that we work through. Hopefully, what you also notice, so I'll recap, that in this staging area, this warm standby. So again, we have a T2 small Cloud Endure replication server to a number of these low-cost magnetic EBS that operates at a ratio of 1 to 15. So we have one replication server for about 15 disks. So to illustrate the advantages of operating the AWS infrastructure in this way, we're comparing 15 disks is probably somewhere around 3 to 5 servers. And the cost of operating a T2 small and 15 magnetic EBS is typically somewhere between $20 to $30. So at that kind of cost, we're comparing operating 3 to 5 servers, which is the capital investment in buying them, the licenses associated to operating system, database, and application, the storage, the labor, the power, the cooling, all of that goes away. All of that goes away to be replaced by simply this low-cost staging area. And then as we need the higher cost compute and storage capabilities, the runtime capabilities, that's the point in time that you pay for it. And when you've finished, you can use Cloud Endure to close down those resources and continue the replication from source to the staging area in the background and in the meantime. Okay. I think Carmen also did a good job earlier, and Matthew too, in expressing that really the way you perform disaster recovery is a business decision, and that business decision is going to be a balance of the capabilities and performance you require and the cost you wish to spend and budget. So Cloud Endure actually has 3 variations of our disaster recovery product to cater for this balance of performance versus cost. So we have the tier 1, which is what Matthew and Transdev are able to operate, which is the sub-second RPO and minutes of RTO. We have what we call tier 2 product, which has an RPO of 2 hours and an RTO of 4 hours. And we have a third variation on this, which is our backup product, which is probably the closest replacement to just using tape backup, for example. So it'll allow you to take very, very low cost backups and store them on the cloud using our same sub-second continuous data protection capability, except for there is no cloud-based recovery. So the recovery is done back to the source only. All right, and then just to finish up, one of the questions that I regularly get asked is this all Cloud Endure? Yes, it absolutely is. You're welcome to go and review any of our patents, but you'll see we have a number of patents to testify the fact that this is absolutely, completely and entirely proprietary Cloud Endure technology. And the other thing that I'd like to make sure that I emphasize is we often get into depth around the InfoSec type discussions. And we always come out the other side with flying colors, which is how we're able to work with HIPAA compliant organizations to manage personally identifiable information, how we work with local, state, and federal organizations, how we're able to work with financial services. We're an ISO 27001 organization. Again, we're an AES 256-bit encryption between source and that staging area. It will follow the data path that you provide, and we work at the physical level, not the logical one, so we have no context as to the data that we are replicating as we perform this disaster recovery. With that, I think it's a good time for me to pause and hand back to Carmen.
Yeah, awesome. Thank you for that. So with that said, and I want to thank Stephen, and I want to thank the Cloud Endure team for presenting today, and obviously I want to thank Matthew for telling the story around Transdev's DR strategy in the cloud. We have some questions, and I want to try and get to as many as possible. So let's just jump right into it. So the first one is for you, Matthew, and folks want to know how you handled failback after recovery of the primary site.
As I said, we scoped the case we want to cover was a real disaster. That means we have something really bad happened, and we had a complete loss of our primary data center. And as I also said, we are on our way to migrate to AWS. So the fallback capability was not in the scope of what we were looking for a solution. We were looking for a way to fail over to AWS. And as AWS is our target in, let's say, midterm for our hosting provider, this capability to fail back was not really what we were looking for. But as I know, what I know about it is that the Cloud Endure solutions has this the ability to provide everything for the failback operation.
Okay, awesome. And then another one to kind of go back into your strategy, and I was talking earlier about the like the game day scenario and your DR tests, right? What was the scope of those tests? Did you fail over production traffic to the DR environment? Like, what did the process look like?
Yeah, that's another interesting question. So we had some constraints, technical constraints that do not permit us to move the production traffic to the DR environment for tests. So we cover the test in a closed environment, and we give our key users access to this new environment, this isolated environment, so they are able to validate at the application level that everything is fine in the recovery process. But as we have everything in our systems is linked. Is dependent on an Active Directory from Microsoft directory, and as it's a distributed system, we would have, if we move the production traffic to this new environment and we keep the two environments connected, we will have a split brain situation that will and things will not go really right. So unfortunately, we did not move the production traffic. We identified all the key users for every application. We gave them the ability to test the application, and we gave them this ability by recovering with as Steve said, with blueprints in Cloud Endure that were really close to the configuration of the source machines. So we try to match as much as we can a real disaster use case, but due to some technical constraints, we were not able to move the production traffic to this new environment.
Okay, awesome. And Stephen, we have one for you around Cloud Endure, and in particular the staging area. There was some interest around that, and the question is does the staging area live in the same region as the target that you're replicating to?
So it absolutely does live in the same region as the target, as you want to create the target. So wherever you want your final destination to be in terms of sort of production capability, that's the region that the staging area will live. Typically, I guess best practice, it's a separate VPC, which is if you remember the architecture slides that Matthew showed, that's what he showed you, but it can be in the same VPC. It just needs to be in its own subnet. So imagine that its subnet is really private for Cloud Endure, but it absolutely needs to be in the same region.
Awesome. And there's another question around the replication itself. And I used to use Cloud Endure extensively in my prior role when I was working with the migration services team here at AWS. And it's a fantastic piece of technology. Maybe you could just talk a little bit about the replication method around, is it synchronous versus asynchronous?
Sure, it's actually asynchronous. And it's what we call this continuous data protection. So what's somewhat different here is the job of the agent is really, as I said, it's just to, after it's done that initial sync, that's when it moves into what we call CDP mode. And CDP mode is where we can create the disk consistency. We write in a fashion that's called crash consistent for those of you that are technically comfortable with the phrase. So we write in a mechanism that's crash consistent using block level replication. So every block gets packaged and passed over to the staging area, at which point it's written onto the reciprocal disk in a crash consistent fashion. And it is written asynchronously.
Awesome. And another one for you, it's around LDAP. Maybe you could talk around use cases with LDAP and Cloud Endure and how that works.
Sure. Well, actually, this year we released our SAML, so Security Assertion Markup Language. We released our SAML 2.0 capabilities, which also include multi-factor authentication. So as long as whatever authentication technology you use is able to adopt to the SAML authentication processes, we're able to support it.
Cool. And another question as well is around performance, right? So, maybe you could talk a little bit about the disaster recovery performance and the scalability of it.
Excellent. Well, actually, this is a good question. This is one that I get asked fairly often, which is, and what we have, we've obviously a demo, which is a live demo, and our demo performs very well. And people look at our demo and they say, look, I see it took you 90 seconds to create that target workload. How scalable is it? And the answer is that it is extremely scalable, because the advantage of the way that we work and the advantage of the AWS infrastructure is that we're able to do everything that we do in a parallel fashion. So it matters little whether or not we are restoring one machine or 500 machines. And it matters little whether we're restoring 1 terabyte or 50 terabytes, because of the mechanism, the process we use, and the capabilities that AWS provides. The scalability is extremely scalable, and the performance is very linear throughout.
Awesome, awesome. And then one more Cloud Endure question, and you can use Cloud Endure to migrate to AWS, or if you move your workload to AWS, how can Cloud Endure help with the DR after you've already moved your production workload into AWS?
Excellent. Carmen, first point, you're absolutely right. So Cloud Endure also does do migration. It's actually exactly the same technology, except for it's a move it once and I'm done. It's also available on the marketplace as well as disaster recovery. But to answer your question, however you get to AWS, once you arrive, you still are likely to have the same sort of questions around, well, what do I do around disaster recovery? And I'm thinking back to the slide that you presented where you had sort of high availability all the way through to disaster recovery. And they're different parts. They weave differently into your strategy around IT resilience. Once you've arrived to AWS, it does not negate your interest, desire, or I think need to evaluate disaster recovery. And what Cloud Endure is able to do is to create the same workflow, the same process across regions. The other beautiful advantage of being able to do region to region disaster recovery is the failback process is a real breeze using Cloud Endure. So failover and failback is very, very easy, fully automated and well orchestrated experience.
Awesome. And I'm going to sneak one last one in really quick, and it was just around like the general backup strategies, and this one I'll take, and it was essentially, backup and restore. Does that constitute a disaster recovery plan, as in my DR plan is to restore from backup? And the answer to that is absolutely, right? So one of the first ones I hit is that backup method, where you can take something as simple as a database, right? So if you think about in traditional IT, maybe you're backing that database up nightly, and then you would do a restore during an outage, or as part of as part of an upgrade to a system. Maybe the upgrade went bad and you needed to restore back to that point in time. That is a completely viable way to handle DR for your application. If you want to read more about that, you can actually go to the disaster recovery white paper up on AWS's website, and it'll walk you through in detail all the various different strategies from DR down to multi-site. So with that said, I want to thank everyone for attending today's webinar. Please remember to stay connected and complete the brief survey at the conclusion of this webinar. We look forward to supporting you in current and future projects. Thank you again to Matthew and Stephen for taking the time, and thank you to the attendees for listening today. Thanks again, and have a great day.